Okay, with the first one, we need to add a carbon, and we end up with a carbonyl compound, which suggests that we would want to use Greenyard chemistry to solve this. However, we would need to have this aldehyde in order to add methyl magnesium bromide to it to do our Greenyard chemistry. And so, that basically shortens the question to how do we go from here to this aldehyde? Well, one way that we could do it would be to start with an anti-Markovnikov addition of water, which goes all the way back to organic chemistry 1. And that reaction is never going to go away, not even in this class. And so that would give us this alcohol, and then we could just oxidize that with PCC to give us the aldehyde that we want. And then after that, we're going to treat it with our Greenyard methyl magnesium bromide, followed by H3O plus, which will give us the alcohol, but then we need to oxidize that again. So to do that, we could use PCC again. So I'll just put that in here, PCC. And just like that, we're done. There is another way that you could do this one, though. No, I think that's probably the best way to do it. Anyhow, let's move on to the next one. And this one, we're taking this alcohol, and we want to make the same compound we did in the first one. And so now we know how to do it, but we need to figure out how to go from here to this terminal alkene. And we can't just heat it with sulfuric acid, because that will give us the Zaitsev alkene, and we want the Hoffman alkene. And so what do we have to do? We have to first convert this into a good leaving group using tazzo chloride and pyridine. And after which we're going to treat it with a hindered base, like potassium T-butoxide, and that will give us this alkene. And then the rest of it is going to be the exact same as what we did in the previous problem. So first, we're going to treat it with chlorine and THF, followed by sodium hydroxide and H2O2. Doesn't matter which order you put them in. Then after you're done with that, we're going to oxidize it with PCC to the aldehyde. Then you're going to do the Greenyard chemistry, so methyl magnesium bromide. The fourth step, fifth step, treat it with water. And then you're going to hit it with PCC again, so PCC. And there you go. There's the entire thing. So that's a total of 8 steps to get to the final product. So 8 steps. There's one more problem that I was thinking about that I thought was a pretty neat one, and that would be to take acetylene. If somebody just asked you, could you take acetylene and then convert that into a big old ketone like this, okay, something like this. All right, and I think the answer is definitely we can do that using the chemistry that we've learned so far in this class. Let's just imagine that our 2 carbons from the triple bond were these 2 carbons here. That would mean that we would need to add 1, 2, we'd need to add 1, need to add 1, 2, 3 carbons on this side and 1, 2 carbons on this side. If we start by adding the 3 carbons on the left-hand side, so first we would treat it with sodium amide, followed by propyl iodide, that would give us this compound. So then we'd have 1, 2, 3, like this. Then we can do an anti-Markovnikov addition of water across the triple bond to give us an aldehyde. So since we have an alkyne, we'll treat this with 9 BBN and then hydrogen peroxide, H2O2 and sodium hydroxide. Then we have 1, 2, 3, 4, 5. So let's see here, 1, 2, 3, 4, 5. We would end up with this aldehyde. And now we just need to add the 2 carbons on the end. So we would use Greenyard chemistry and treat it with ethyl magnesium bromide, followed by H3O plus. And I'm kind of running out of space here. 1, 2, 3, 4, 5. And then we have 6, 7. There you go. So now we've got our secondary alcohol. And in order to convert that to the ketone, we could use Swern oxidation, desmartin periodinane, PCC, a chromic acid. So I'm just going to use a Swern just for fun. So first step is dimethyl sulfoxide and oxallyl chloride. And then in the second step, we treat it with triethylamine. And again, this is the Swern oxidation or Swern reaction.